Last class, we went over adding, subtracting, and multiplying. That leaves division for today. Okay. So the first thing we want to understand is whenever a question asks you to simplify a radical, it's not simplified if there is a radical in the denominator. Okay, so yeah, all these problems are not currently considered simplified because they all have a radical in the bottom of the fraction. Okay, so there's actually two different situations that we need to treat differently. The first type of problem is when the denominator is a monomial. Okay, so as a reminder, monomial means one term. So no adding and subtracting. Okay, so the way that we handle this situation, right? You see both of these examples, the denominator is a monomial. Even though this one looks really complicated, it's all one term. There's no adding or subtracting. Okay, so the way that we fix these, we're going to multiply both the numerator and denominator by, we'll say by the missing factors. Okay, so our goal is to make the radical disappear in the denominator. So we know that the only way to make a radical sign disappear is to empty it. Okay. So we'll see some examples soon of what it means to find the missing factors. Okay, and then like always for radical problems, after you've done whatever the original operation was, you simplify. You try to take anything out of the radical, or you cancel out any common factors of the numerator and denominator. Okay, so looking at our first example, right now this is not simplified because in the denominator is a radical. Okay, so how can we get rid of it? We need to multiply by something. Okay, so we don't know by what yet, right? But we're going to multiply by some fraction. Okay, so sort of like when we completed the square, right? We jump ahead a little bit and then we go back and fill in the previous step. Okay, so right now this 7 cannot move outside, right? It's not, the index is 2. This is currently 7 to the first power, right? So the 7 can't move out. So our goal, jumping over here, our goal is to make it 7 squared on the inside, right? Because if we can get to here, then the 7 has the correct exponent, right? And then now the 7 will get to move outside. Okay, so this is the goal, right? We want to end up here because then the 7 moves out, the radical is empty, and the radical disappears. Okay, so again, make sure you understand the goal, right? The goal is to make the exponent match the index. Okay, so for this problem then, right, now we need to figure out, okay, what do we multiply the original denominator by to get to this denominator? Okay, so we always multiply by the same type of radical. So this is a square root. Okay. And then what do we multiply the original inner 7 by to end up at the goal of 7 squared?
1 squared.
Not 1 squared.
Oh, just squared.
You can't do a squared.
Oh.
Pin 7. If you multiply the original 7 by a second 7, that becomes 7 to the power of 2. Okay, so whatever you multiply the denominator by, you multiply the numerator by the exact same thing. Okay, so the denominator is already there, but now we need to go ahead and multiply together the numerator. So remember, you multiply the outsides together. So there is an invisible 1 here. So 5 times invisible 1 is just a 5. And then you keep the radical 7 because there's no radical up here to affect it. Okay. And then the denominator, right, we already simplified. The whole point was to take the 7 out. So it's regular 7 now, not radical 7, because the radical disappeared. And we now do the last step, simplify. Okay, in the numerator, 7 is a prime number. You can't split it up at all. You cannot divide the radical by the non-radical. So you cannot divide these 7s by each other because this one is square root 7, this one's regular 7. Now you could divide these numbers if they had anything in common besides 1. But 5 and 7 just have 1 in common. So that means this is our final answer. Okay, so you're allowed to have radicals in the numerator of a fraction on top. You cannot have a radical in the denominator. Okay. So now let's try to fix the second example. Again, it's not currently simplified because the denominator has a radical in it. So again, we're going to multiply by some mystery fraction. But to figure out what that mystery fraction is, we jump to the next spot over. Okay, so our goal for this problem is to completely empty this radical. Okay, so this one's a cube root, not a square root. So since the index is 3, we can only move things out if their exponent is 3. Okay, so the 5 needs to become to the power of 3. And the x squared also needs to become to the power of 3. Okay, so again, last problem, because it was a square root, we wanted things to become to the power of 2 on the inside. This time the index is a 3, so we want the inside to be exponent of 3 instead. Okay, so now we can figure out what to multiply by. Again, you always use the same type of radical, so it's going to be a cube root. Okay, so we need both the 5 and the x to end up with an exponent of 3. Okay, so let's just start with the 5 part of it. Right, 5 times what equals 5 cubed? Dominic?
It's actually going to be 5 squared.
Perfect. 5 is currently to the invisible first power. So when you multiply by 5 squared, you have 1 here times 2 more here. gets you 5 to the third power. Okay, and then now let me see if there's a different student who can tell me what do we multiply the x squared by to end up at x cubed? Ethan? No? Okay, that's fine. Angel? 1? The number 1? Oh, a single x to the first power. Okay, so that's right. X squared times a single x to the invisible first combines to x to the third. Okay, so good. Yeah, for this problem, you notice it's not the same thing we started with. You just multiply by whatever is missing. Okay, again, to get to 3, you already had 1 5, so you need 2 more 5s. On the other hand, for the x's, again, you need 3, but you already had 2 to start with, so you only need 1 more. Okay, so now that we know what to multiply the denominator by, we multiply the numerator by the exact same thing. Okay, so the 2x has an invisible 1 on the outside, so 2x times 1 is still 2x. Okay, now we're going to move whatever we can out front. I'm going to start with the denominator. Right, the whole point was that radical needs to empty in the denominator. So the 5 gets to move out, and the x also gets to move out. Okay, so the denominator is regular 5x, and the radical is empty, so it disappears. Okay, now for the numerator, we check, can anything move out? The 5 has an exponent of 2, but it would need a 3. So the 5 does not get to move out. Same thing with the x. The x has invisible 1. That's not enough to match the index of 3. Okay, so both of these stay inside the radical. Okay, so you still have the 2x on the outside. You still have the cube root. But instead of leaving it at 5 squared, let's just turn it to 5 times 5, which is 25. And then you still have the regular x. Okay, and then last step, as always, try to simplify. The 25 and the 5, you're not allowed to divide because, again, the 25 is in a radical, the 5 is not. Same thing, you can't divide this x and this x. But you are allowed to divide the coefficient x with the denominator x. Right? These are regular x's, they're not radical x's. Okay, so we are allowed to cancel out the common x factor. Okay, so that leaves 2 cube root of 25x in the numerator and just a 5 in the denominator. Okay, there's no more reducing. The 2 and the 5 can't divide anything except 1. Okay, so yeah, that's the strategy. Multiply by a blank fraction, but then jump ahead, figure out what your goal is to empty the denominator, and then figure out what you need to multiply by. All right, so go ahead and take a couple minutes, please, and try the 3 problems in the practice section below. All right, so for problem 1, we, again, multiply by some fraction to figure out what fraction we look ahead. It's a square root, invisible index of 2. So the only way the 6 can move out is if it becomes a 6 squared, right? Because you want the inner exponent to match the index. Okay, so we ask ourselves, how do we get from regular 6 to 6 squared? By multiplying by another 6. 6 times 6 is 6 squared. Okay, so you multiply both top and bottom by that number. In the numerator, invisible 1 times invisible 1 is still 1. On the inside, 3 times 6 is 18. And then now the 6 gets to move out. Okay, so a few of you were able to get to here, but then you stopped. This is not considered fully simplified yet. The 18 inside the radical that can be rewritten as 2 times 3 squared. So the 3 gets to move out. And once you get to this point, again, you can't divide the radical with the denominator, but you can divide its coefficient and the denominator. So 3 and 6 can both be divided by 3. So that leaves us with radical 2 over 2. Again, you don't write the 1 in front. 3 divided by 3 is 1, but it gets absorbed by the radical 2. Okay, so a fully simplified answer is radical 2 over 2. Okay, for this next problem, again, multiply by some empty fraction, but look ahead to your goal. Because the index is 3, you need the inside to have an exponent of 3. Okay, so you're only starting with an x to the invisible first power. So to end up at the third power, you need 2 more of them. Okay, so numerator, the 7 just goes in front. The whole point was we want the denominator to empty, so the radical goes away. Okay, and again, you can't divide the radical with the non-radical, so this is it. Okay, and then lastly, you had a fourth root of 2x. Okay, so the index of 4 means you need both things on the inside to be to the fourth power. Okay, the 2 needs to be to the fourth, and the x also needs to be to the fourth. Okay, so you always multiply by the same radical, so index of 4. Right now it's 2 to the invisible first power. So to get to the fourth power, you need 3 more 2's. Okay, and same thing with the x. Right now you've x to the first. To end up with the 4, you need 3 more. Okay, so in the denominator, again, the radical should always empty. In the numerator, nothing can move out. Exponent of 3 isn't enough to match the 4. So 2 to the third will just turn into an 8. X cubed will stay x cubed. Okay, but this is not the final answer because we do have an x in common on the numerator and denominator. Okay, so we are able to cancel those out, making the fully simplified answer the fourth root of 8x all over 2. Okay, so remember all of these problems, the denominator was a monomial, right? There's no adding or subtracting anywhere in the denominator. Okay, so are there any questions about these 3 problems, Angel? The 2 cubed that we multiplied by over here, right? 2 cubed is 2 times 2 times 2, which is 4 times 2, which is 8. Okay, other questions? Okay. All right, so the other situation is when the denominator is a binomial. Okay, so let's remind ourselves that binomial means 2 terms added or subtracted. Okay, so if you look at the denominator here, this is a binomial. There's a 5 and a radical 2, and they're separated by a plus sign. Okay, so that means that we need to use a different strategy. Okay, so we can't do the same thing as above. It wouldn't get rid of the radicals. Okay, so the different strategy that says multiply. Okay, so we know whenever you multiply a fraction, you got to multiply both the numerator and the denominator. Okay, so this is a new vocabulary term, a new mathematical concept. You're going to multiply by what's called the conjugate of the denominator.
What is conjugate?
Yeah, let's go ahead and define that. So the conjugate is identical except the middle symbol is switched. Okay, so let's go ahead and see this first problem. Okay, so right now the denominator again is a binomial, two terms split up by a plus sign. So let's go and put parentheses around it so that we can make sure we distribute properly. Okay, just like before, we're going to multiply by a fraction. But in some ways, this is actually easier because we don't need to write a blank fraction and then jump ahead to the goal. We already know right away what we're going to multiply by. We're going to multiply by the denominator, but with the middle symbol switched. Okay, so keep the positive 5 in front, keep the radical 2 in back, but switch the middle symbol. So instead of a plus sign, make it a minus sign. Okay, and then the numerator, again, whatever you multiply the bottom of the fraction by, multiply the top by the same thing. Okay, so we need to make sure we distribute here. Right, so in the numerator, we have 5 times parentheses 5 minus radical 2. So again, you might want to organize that with the boxes or with the arcs, either way. Right, so first we have radical 5 times regular 5. So the regular 5 goes in front, the radical 5 is unaffected. And then you have radical 5 times negative radical 2. In front, you have positive 1 times negative 1. So that's negative 1. Sorry, let me write it out. Okay, so again, positive times negative is negative. And then on the inside, 5 times 2 is 10. Okay, so the numerator is 5 radical 5 minus radical 10. Okay, and then the denominator, we have two binomials multiplying each other. So because both of them have two parts, we need to do the bigger box, the one with 4 squares. Okay, so one of the sides will be 5 plus radical 2. The other way will be the second parentheses, the 5 minus radical 2. Okay, so top left box, right, is 5 times 5, which will be 25. Top right box is 5 times radical 2. So positive 5 radical 2. Bottom left, you have negative radical 2 times 5. So the negative in front multiplied by the positive 5 becomes negative 5, and you keep the radical 2. And the bottom right one, you have negative radical 2 times positive radical 2. So negative times positive is negative. And then on the inside, oh, sorry, let me write it out. They have negative radical 2 times positive radical 2. So again, negative times positive is negative. And then on the inside, you have 2 times 2. I'll write as 2 squared. Yes, it's 4, but I want to write it as 2 squared instead. Okay, so taking those 4 boxes, I'm going to write them out in a row. Okay, so now we're adding and subtracting. We learned last class, the rule is that you need to have the same radical, meaning the radicand and the index have to match. So these are both square roots, and they both have a radicand of 2. So we are able to pull these two together. And you keep the radical. The 25 is still there, so let's not forget that. Over here, you have a square root and a number squared. So we are allowed to take the 2 out. Okay, make sure you keep the minus sign, so it's minus 2. Okay, now in the middle, right, we combine these two terms. 5 minus 5 is 0. So 0 radical 2 is 0, right? Okay, so we have 25 plus 0 minus 2. 25 plus 0 is 25, minus 2 is 23. Okay, so you see our denominator, all the radicals disappeared. The two middle radicals canceled out, and the radical at the end got emptied. Okay, so if you still have a radical in your final answer, that means you made a mistake for sure. You're not allowed to have a radical in the denominator. Okay, so let's try the next one sort of together. We'll go back and forth. Okay, so first, try to figure out what are we going to multiply the original problem by? Okay. Would anyone like to raise their hands and share what they think? Go ahead, Dominic.
So it's actually -1 plus 2 square root 5.
Very good, thank you. You keep the -1, you keep the 2 square root 5, but then you switch the middle symbol, in this case from a minus to a plus. Okay, now don't do the conjugate of the numerator. You always multiply numerator and denominator by the exact same thing. Okay, so here there's a lot of parentheses needed. Okay, so yeah, you're gonna have to, do the multiplication for both the numerator and the denominator. And here, both of them are gonna require, distributing or drawing the box. Okay, so this one's for the numerator. Okay, so -1 times -4 is +4. -1 times positive radical 3 is now negative radical 3. 2 radical 5 times -4. 2 times -4 is -8. Keep the radical 5. And 2 radical 5 times radical 3. The 2 stays in front. On the inside, 5 times 3 is 15. Okay, so writing that out, we get 4 minus radical 3 minus 8 radical 5. And this is positive, so plus 2 radical 15. We check if we can simplify this. 3 is a prime number, 5 is a prime number. 15 is 3 times 5, but nothing is squared. Okay, so we can't simplify and none of these can combine. Okay, so the numerator is all of that. Okay, and then we'll also want to multiply the denominator together. All right, -1 times -1 is +1. -1 times -2 radical 5. In front, negative times positive is positive. Keep the radical 5. Over here, 2 radical 5 times -1. Negative times positive is negative. Or -1 times +2 should be -2, and then keep the radical 5. And this last multiplication is very commonly missed, so let's make sure we do this correctly. First in front, +2 times -2 is -4. And then inside the radical, 5 times 5 is 5 squared. Okay, so let's just write those 4 boxes first. Okay, so if done correctly, the middle 2 should always cancel out. It should always be plus and minus the same number. Okay, so I'm not even going to show the work like I did last problem of turning it into 0. The middle 2 numbers should always cancel out. Okay, so let's keep the 1 in front. That did not get canceled out. And then over here, the 5 gets taken out to join the -4. Okay, so when you take numbers out, they multiply what's already there. Okay, so again, keep the 1 in front. But now -4 times +5 is -20. And then lastly, 1 minus 20 is -19. Okay, so all the radicals went away, which is good. Okay, so -19 is your denominator. And that's the final answer. Okay. All right. So on the top of the back side are 3 practice problems on this topic. So please take a few minutes and try to do the next 3 problems.